Okay, we're going to finish up the year with lesson 74, complex fractions, and I'm not quite sure what I'm going to do with lesson 75, so I'm still working on that one. But 74, complex fractions are simply fractions in fractions. You know, we've had, and I'm actually going to erase it as a problem, but we've had situations where we ended up with something like maybe 2/3 over 5/8, maybe something like that. That's a complex fraction with no variables in it. And we would just treat it as a division problem. And then we know KFC, keep the first one, flip the second one, and make it multiplication. And then in this case, there is no canceling, so I've got 16 over 15. The easiest way, especially when you throw variables into it, is to take them instead, take the top and the bottom, and multiply by the least common denominator of the two fractions. So the smallest number that 3 and 8 will go into is 24, and we're going to multiply it as a form of 1. That's why it works. And when you cancel, if you're doing 2/3 times, because in reality, here's what you're doing, 2/3 times 24 over 1 on top, and 5/8 times 24 over 1 on the bottom. And then you get 16 on top, and you get 15 on the bottom. Now that seems a little more complicated, but especially when you get some variables in it, it can get a little crazy. Let's do 25 over 2 over x squared over 5. Now with each term, the numerator, denominator being just monomials, one term, not a binomial or anything like that, you could just about do it either way. But using the method that they're talking about, we're going to take the common denominators, the common denominator of 2 and 5, which is 10, and we're going to multiply by the top by 10 and the bottom by 10. And I'm actually writing it to where you can kind of see you're actually multiplying by the 10 over 1 on the bottom and the 10 over 1 on top. So you can cancel your 2 and your 10, and you get 125. And you can cancel your 5 and 10 and get 2x squared on the bottom. And that's in lowest terms. Your goal is to get rid of those denominators because it's not simplified if you have a fraction and a fraction. So if you can get those denominators, what you're actually getting them to is ones. You're canceling them to ones. And so then you've got 25 times 5 over 1, which is 125. And x squared times 2 over 1. And that will give you just one numerator and one denominator. Let's do m over 3 over m over 3m plus 9. Now, we want the common denominator of our denominators, but the first thing we want to do with this one is factor it, because to get the least one, we need to know what they have in common, because remember, the least common denominator is what they have alike. They both have a 3, and this one has an m plus 3. So everything you see has to be in the common denominator, and you're multiplying by 1 over 1. Notice the 3's cancel, because remember, we're multiplying top and bottom. 3's cancel, and we're left, let's see, what do we got here? We got an m and an m plus 3. And then on the bottom, 3m plus 3 cancels. Both of those cancel, and we're left m. So one more reducing. We can cancel our m's, and we're left m plus 3. Oh, I'm sorry. I got off screen there. There you go. So we canceled these. Again, when you multiply that denominator on top, you're actually doing it over 1 so that you can cancel here and here. And that leaves you m times m plus 3 over the 1 on top. And m, and then everything canceled here, left you a 1, 1. So you got m times 1 over 1 is. Okay, number 3. 3 over 25 is my numerator, and I got a big denominator. I've got m plus 5 over 3 plus m plus 5 over 9. Now, we need a common denominator of 25, 3, and 9. Well, the way I looked at it was the common denominator of 3 and 9 is 9, and the common denominator of 25 and 9 is going to be the product of those two, which is 225. So I'll multiply by 225 on top. and 225 on the bottom, but I'm going to have to distribute it to both of these. So I'm actually going to show it like this. I'm going to go ahead and do it like this. I'm going to distribute the 225 to both of these. So on top, 25 goes into 225. Remember, that's your goal, is to get this to a 1. So you want to cancel. It goes 9 times. And then on the bottom, 3 goes into 225 75 times. And then we'll distribute that, and we'll get 75M plus 75 times 5 is 375. And then the 9 goes into 225, 25. Again, that makes these 1s. And we've got 25 times M is 25M. Plus 5 times 25 is 125. So cleaning up that denominator, we have 100M. And we've got 500. Now, there is a GCF of 100. Sorry, here you go. There is a GCF of 100. But nothing will cancel with a 27, so we're going to leave it without parentheses. Okay, number 4. We've got, let's do 4x. Now, I'm going to leave a line here, and you'll see why in just a second. Over x over 4 minus 4 over x squared. So this is my numerator. And this is my denominator, but notice I have fractions in my denominator. You can't have fractions in fractions. But I'm going to make this one a fraction by putting a 1 under it. You need to do that if you're given just a term without a denominator. That's how you make a number a fraction, because in terms of common denominators, it's the 1, the 4, and the x squared, not the 4x. That was your numerator. So 1, 4, and 1 all go into 4. And if you remember, it's the most variable you see. So I have x squared. So I got to have 4x squared. And so I'm multiplying 4x over 1 times 4x squared. And it doesn't cancel because it's 4x squared over 1. So I have 16x cubed on top. And then on the bottom, when I distribute this 4x squared, my 4's cancel and leave me x cubed. And my x squareds cancel and leave me minus 16. Now, you can't cancel these. These won't factor. This is not a difference of 2 cubes. It won't factor. Even if it did, there's nothing that would cancel. And remember, it has to be multiplication, which this is not. And there's your answer. A lot of times, it's really just cleaning it up, the final answer. Let's do, let's see. Let's do 1/3 minus 1/2 over x plus 5 over 9 plus 2 over 9. Okay, look at all your denominators. 3, 2, 9, 9. So 3 and 2 is 6, is the least common denominator. And 9 and 6 and 9 will both go into 18. So the easiest common denominator is going to be, oh, I don't want my equals right there. I want my times right here. Times 18. And we'll distribute it to both, well, actually to both of these. 18 here, 18 here, 18 here, and 18 here. And your denominators are going to cancel because that's why we're doing this. We're trying to get rid of those denominators in the fractions. So 3 goes into 18. 6 times 1 is 6. 2 goes into 18. 9 times 1 is 9. 9 goes 2 times. 2x plus 10. And 9 goes to 18. 2 plus 4. So we get negative 3 over 2x plus 14. Now I noticed on that one they did put the negative instead of up here, they actually put it out front, but I think you would recognize that. And let me see if there's another one. Yeah, let's do one more. Number 6. 3 over 10 minus 5 over 3 over x over 5 plus 5 over 2x. Now, these can get super wild. You can get a lot of fractions in them, more than 2. We're just trying to just scratch the surface to kind of finish it up so that you've been exposed to these. 10 and 3 would be 30. Well, we actually could go ahead and do the 10, the 3, the 5, and the 2, and the least common denominator of those is 30. And the x, so you got to have an x in it. So let's distribute the 30x to each one of these. Okay, 10, so that leaves me 9x minus 50x over 6x squared. See, and the x will cancel, and that gives me 15 plus 75. Okay, do we have any GCFs? I can take an x out. Oh, I can go ahead and put those together. Negative 41x, I don't know what I was looking at, over 6x squared plus 75. So a lot of times your arithmetic is pretty easy once you get your canceling, and then just clean up your terms.